multiply by to turn root 3 into a normal number? Square root 3, yeah. If I multiply the denominator by square root 3, it'll turn it into a normal, it'll be 3, won't it? Root 3 times root 3 is 3. But if I don't want to change what this original thing was, what do I have to multiply the numerator by? I'd have to multiply the whole thing by 1, which wouldn't be 1 over root 3. What would it be? Root 3 over root 3. That's definitely 1, isn't it? It fits in once. And that's exactly what I have to do. To rationalize the denominator, if it's a single fraction like this, we just multiply by the denominator over the denominator. Okay, which now I haven't worked out what the answer will be. 7 times root 3 is just 7 root 3s, and root 3 times root 3 is just 3. Square root 9 if you want, and then 3, but it is just 3. Let's do another example. Let's take the second one here. So these are, if it's a single fraction, it's really straightforward. I just multiply this by root 5 over root 5, whatever this denominator is. So this gives 10 root 5 on the top. 10 times root 5 is just 10 root 5s. And on the denominator, we get root 5, which is just 5. Now, sometimes you can simplify. Do you see how we can simplify this a little bit? Yeah, because 5 fits into 10 twice, which gives me an answer of 2 root 5 over 1 if you wish, but we don't usually write over 1. It's just 2 root 5. The last one here, what happens if there's another number in front, a multiplier? I think that's what it's the same question, but with a different number. Right, what do I multiply by? I suppose the choices are, do I multiply by 3 root 2 over 3 root 2, or do I multiply by root 2 over root 2? The answer is you can use either. Both will get rid of the square root. You'll just have to simplify. I'll do both. I'll do 3 root 2 over 3 root 2. And in the second example, I'll just do root 2 over root 2. This one, I get 30 root 2 in the numerator, and I get 9. Well, 9 times root 2 times root 2, which is what? Well, let's write it out. Root 2 times 9, which is 9 times, this is 2, isn't it? Root 2 squared. So that's 18. So I get 30 root 2 over 18. Now I can simplify the 30 over 18 to give me I know it's going to divide in, well, 2 definitely divides into both. So that's 15 root 2 over 9. Is that? I can divide by 3, yes. So that gives 5 root 2 over 3. That's about as far as I can go, yeah. Let's now do it without the 3 root 2. Let's just do it normally. So that's 10 root 2, 10 times root 2. And this gives 3 root 2, which is 3 times 2. Let's write it as well. 3 root 2, root 2s. So that's 10 root 2s, lot of square roots and surds. Shock, because that's what they are. That gives 3 times 2, which is 6. And now I can simplify this. And I get 5 over 3, don't know if I divide them both by 2. So I get the same answer. So if you're worried about what to pick, you can do either of them. I would have picked this way, because it's quicker, less simplifying. Why did you write this one, if this one is the quicker way? No? You okay? All right. Annika's shocked. Okay, so that's the simple one. If it's just a single fraction, you could see some more difficult ones coming up. I might jump straight to the last one. What happens if it isn't as simple a fraction? We have something like this. And I have to write this in the simplest form. Now, I can't have a square root in the denominator. That's what this means. Rationalizing the denominator means make the denominator, the bottom of the fraction, a rational number. So not a square root number. Just these square root numbers are irrational. Surds are irrational. So what do I multiply by? Any ideas? You have to multiply by something over something. It has to be equivalent to 1. Any idea? No ideas? Nothing? Root 3, that's a good idea. That's probably what I would think of as well. So if I multiply above and below by root 3, what do I get? Let's just look at the denominator, because I need the denominator to be a rational number like this, like a 3 or a 6 or something. So what do I get? Root 3 times both these, remember, so you have to do a proper multiplication. Root 3 times 1 gives root 3, plus root 3 times root 3 gives, well, 3. So my problem is I still have a square root in the denominator. That hasn't rationalized the denominator, but it is where you probably would think of first. So that doesn't work. So what will work? I've drawn an extended line. I have to put 2 terms to multiply it by. I'm going to multiply by something called the conjugate. How does this work? Well, this is like the difference of 2 squares. You lose the middle term. Let's see how it works. I'm going to multiply the top and bottom by the conjugate of the bottom. Now, the conjugate means opposite sign for the second term. Opposite sign, that's what conjugate means. How does this work? Well, let's just do the denominator, which is going to be a 4-term multiplication, because 2 terms times 2 terms is 4 multiplications. 1 times 1 in my denominator gives 1, so that's these first 2. 1 times minus root 3 gives minus root 3. Now, 1 times plus root 3 gives plus root 3. And then root 3 times root 3, but it's minus. Root 3 times root 3 is 3, and it's minus because this one's a minus. What has happened that is convenient? This will cancel with this. And this will always happen if you multiply by the conjugate, the opposite sign. The same numbers, but the opposite sign in the middle. We should maybe remember it from the difference of 2 squares, a squared, b squared, a minus b, a plus b. This factors 2 from algebra. Maybe not. But that's the same principle. So what's my answer? My answer, I haven't got it yet, but I'm getting there. I have to do the numerator too, which is another 4 multiplication. 1 times 1 gives 1. 1 times minus root 3 gives minus root 3. This times 1 gives what it is, minus 2 root 3. And minus 2 root 3 times a minus root 3. That's going to be minus 2 root 3 times minus root 3. Maybe I'll tidy that up in the next line. This times this is this. That's times. All right, we have a lot of tidying up to do. What's my denominator? Minus 2. Is it okay it's negative? Yes. It's still a rational number, still an integer. What's the numerator going to be? Well, let's just tidy up this bit first, above it. 2 root 3 times minus root 3 is what? First of all, there's going to be 2 minuses here multiplied, so that's a plus. What's root 3 times root 3? 3, or root 9, which is 3. So 2 times 3 then gives 6. So root 3 times root 3 is root 9, which is 3, and that 3 gets multiplied by the 2 to give 6. Now, I have a 6 here and a 1 here, so that's 7. And I have minus root 3 minus 2 root 3, which is minus 3 root 3s. Okay. Where's the 7? 7 comes from this one and this plus 6. Now this simplified to plus 6. Let's do the middle example as one final simple example, and then I'll let you guys go. Yeah. What do I multiply by? Anyone give it a shot?
3 minus root 2.
Exactly. 3 minus root 2, 3 minus root 2, the conjugate. I'll get rid of all this. Okay. The numerator is pretty easy. It's just 3 minus root 2. The top of the fraction, that's times 1. This 3 multiplication, I'm going to get. What will I get? Does anyone can do it quickly? Anyone see a quick root I could do? Do I need to multiply all 4? I know already, because I picked the conjugate, that the middle 2 will do what? Always cancel out. They'll always cancel out. That's why you did it. The middle 2 are going to cancel out every time. So you don't even need to multiply the middle 2. You just need to square the first one, square the last one. Difference of 2 squares. So what is it? What is it? Okay, if you're not sure, we'll do it out fully. See if you can get there faster than me. This is 9. This is plus 3 root 2s. Sorry, that was minus 3 root 2s, the first one. Minus 3 root 2s. This is plus 3 root 2s. This one becomes plus root 2 times minus root 2, which is going to give me a minus 2. These 2 cancel, and we get 7. Yeah. 3 minus root 2 divided by 7.
I don't understand how you got 7 minus 3 square root 3.
On this one? Yeah. The 7, you're not sure where the 7 came from? Oh, well then, this is minus 1 root 3. Minus, yeah, when it's just root 3, there's one of them.